Hello everyone. So I'm Danny, and I'm going to tell you a little bit about crazy user activities in social web networks as expressed in videos. So I hope it's a fun topic and you will enjoy my lecture. So I was introduced, but I have here with me also Dr. Amir Alush, who is, this is joint work with him. He's CTO of our startup. And we have a co-founder who is a professor in Stanford. He's a well-known researcher, Professor Carlos Gestrin, and he's a co-author of XGBoost, Apache TVM, Lime, so he's pretty well-known in the machine learning community. Yeah. So when I started to prepare this presentation, I had a very high bar because I lectured here last year. And I think my presentation was the best probably last year, so I had to do something more interesting versus last year. And last year I was talking about quality of visual data. I was mainly working on visual data sets, like image data sets. For example, ImageNet, that's a very well-known, well-citated data set with 30,000 citations. And I was showing different kind of weird things that come up on this data set. So those are two fun examples from last year. But this year, I think the lecture will be even more interesting because we started working on much larger scale data sets. So we are talking now on not just on images, but also on videos, and not just on small data sets of video. We're talking about billions of videos. So then the problem is becoming way more interesting. So for example, one of my liked network is TikTok network. It's a crazy user activity network, more than 1 billion users. They upload slightly less than 1 billion videos a month. So maybe they are a little lazy. Not all the users are working all the time. But all the other networks are kind of similar. So also Telegram has close to 1 billion network users. Facebook has 3 billion users and so on. So the amount of visual data is really exploding, and we're kind of trying to figure out what's going on there. When thinking about it, why do actually people interact with this social network, what they do there? So I guess either someone wants to be famous, or maybe someone wants to make money. That's my explanation, either of those two things. But it's a bit weird human behavior. And I'll show you why I mean weird. Because if I want to attract a lot of viewers, I have to be very interesting. And the question is, what is interesting? And that's a question that is not fully well defined. It's not an academic question which is fully solved. And this is the kind of thing that I try to, at least to surface the problem and how we are suggesting to solve it. So I'll start showing by three hand-picked examples of what I mean interesting videos, which are all videos around food. Food is something that attracts people in social networks. So the first one is from Israel. We have someone here on a surfboard having a stove, burning stove, a gas stove, and cooking a famous Israeli dish called shakshuka. So that's a fun one, and I didn't put the audio because it's speaking in Hebrew and no one will understand, but he's a bit complaining about the waves. The waves today are not so good, but they can still cook, and it's fine. The second video, I think also you will find interesting. It's a barbecue. It's they're doing a kebab, but what's interesting about this video is where the food is prepared. So it's prepared inside a moving car. So I don't know if it makes a lot of sense with all the smoke and all that, but that exists in TikTok. The third video, which is also a bit hilarious, this is the US side, so not just the Israelis are crazy, we have crazy US persons. That's a Delta flight, and the person is cooking inside the sink of the toilet, and is cooking shrimps and and gravy. Yeah. And after he's cooking, he put it in a bag and actually eats it very nicely. Yeah. So overall, you see what I mean I'm a bit of a victim of watching and analyzing all those activities. But what's interesting about these activities is, so they're all about food, that's a common. They're all in an unusual location, and I will risk guessing your reaction. Who thinks that the first video is the most crazy one? No, no one. The second video? Also no one. The third video? Everyone says, okay, I agree. And there is a reason why the third video is the most funny, because there is a growth factor, an element that things are done inside the toilet. So it's even more crazy, besides cooking on it. So if he was cooking on his seat, it should be fine. So basically what we see here is there is an outlier to the outlier, okay? So we find an outlier class of people cooking in weird places, but there is an outlier to the outlier because if you cook in a weird places, but it's also you cook in a sink of a toilet, it's more outlier than the regular outlier, okay? And that's got us thinking about how we can formalize what's outlier and what's an outlier to the outlier. So I did a little experiment. I asked ChatGPT, what do you think would be most crazy places to cook further if I want to be a famous social network person? So ChatGPT suggested underwater during hurricane on a roller coaster. I tried to look for those suggestions. I didn't find anything. So ChatGPT is a bit forward thinking. If you want to be famous, that's the next thing you need to do in a social network. Now I'll show something slightly different. This is a movie of someone ironing their cat. Maybe it was wet, I don't know. So that's when you have my philosophy that actually it's very weird, but if you will think about it, we probably will find someone ironing his dog, his horse, his cow, and so on. It should be same class of activities. Next one, I think you also like. Someone is shaving. I see people are taking pictures. Okay, someone is doing a regular shaving activity with unregular tool. So that's pretty crazy. So if we summarize what we've seen so far, what's common about those outliers? So we have three common things. One is you have to do very bizarre and weird things to get popular. The second, it should be, or it should be some kind of funny. And the third, you have to be crazy and do dangerous things, and then maybe you will be liked in a social network. But it's kind of the common themes around the social network activities. Now, as you may heard, I was doing a postdoc at Carnegie Mellon. I was working in graph analytics, and that's my trade. And whenever I think about a problem, I think about underlying graph. So what if we could think about those outliers as cooking things in weird places, as some kinds of nodes in the graph? They will be some kind of the outliers of the graph, but they are nearby each other because they are similar. What if we could do this modeling in order to model all the social networks in the world, billions of videos in such kind of structure? So that's what exactly we're building. And we're building a platform that can actually connect to the huge pool of visual data, images, and videos. And we build a graph structure which have all the connectivity between the nodes. And then we can surface quality issues like duplicates, outliers, and so on, duplicates, corruption, and so on. But outliers are the one of interest for this talk. That's one of the things we are focusing. And this can be used as an API or can be used as an analyst tool to find those outliers. And in a second, I'll show you how it looks like. And this is the mention for our paper. If anyone is interested in academic work, that's the paper. It was about 11 years ago. But very recently, we won some prize, which was a fun, after it was, let's say, a failed academic career, but still we had a delayed prize, which is nice. So in order to build a graph, what do we need? We need to take images and videos, split them into frame, do some form of embedding, and then construct the graph. So for that, we build an open source tool called FastDupe. It's super popular. The slide is not up to date. We almost got to 500,000 installations in 2 years. And this is a popular GitHub project you're all welcome to encourage to try out, where basically you can take a pool of images, we do the magic for you, and then we do the understanding. You get the output with mainly quality issues about outliers, corruptions, duplicates, and wrong metadata that is coming with those images. So that's pretty popular, and we have tons of companies using us. We have non-commercial license. It's for evaluation, but all the big enterprises, they just ignore it. It's useful, and some of them are also paying customers, which is nice. So in order to summarize what we want to do, we want to basically share to the world what's going on in a huge amount, billions of videos in social networks, and now we're building the platform to help STIS. So we have the low-level engine, which is the open source FastDupe that allows you to build a graph, but we need another visualization layer that can help you interact with the social network and do those experimentations. So the way it works, we connect to the organizational data sources, we underlyingly build a graph, we organize the data, gives you a way for free-form exploration. We also do some enrichment in order to cluster similar images and videos together, and we allow for extraction whenever we want to get meaningful subsets for downstream training, we can extract this information. So let me show you some demos. I can be a little risky and try to do an online demo, but if not, I have a backup video. Because I was not allowed to bring my laptop, but eventually the conference relented, so this is our real platform, hoping it will work smoothly on wireless connection of a conference, which I see is not. Oh no. So I think the network is down. Yeah, so maybe we'll go for, let's see, pray for me. Okay, let's say, I hope the network is not down. So what we have here, this one is a YouTube data set. We took 15,000 movies. I have also a lot of social network data sets. It's the same, it's video sources. What we do, we first do the feature vector embedding, we do the graph construction. Based on the graph, we learn quality issues, so we remove duplicates and outliers and all kinds of corruptions. And then we are able to, for an analyst, to show what's going on in the data set. So we do unsupervised clustering for the data. And for example, we have a cluster of fireworks. And specifically, an analyst can look at different types of fireworks, and when there is a fireworks of interest, they can go to the specific frame, and then if the internet is working, we will pull the video. And the video is coming from the specific second where this firework happened. The next thing we can do in order to help you find interesting things is a free text search. So for example, you can ask for a woman with a striped shirt, and you get all the women with striped shirts in this video pool, and you can always relate back to the specific video. The next thing we do also object level understanding. So for that, I will show a fun data set from a social network. So this is a data set which is focused around drug dealing on a social network. So what we have here, we have some famous user that uploaded 952 videos of his drug activity. Now, most of these activities are around grass, like weed, and I actually didn't know all the illegal weed type because I'm not a regular consumer for, for this thing. But I can show you there is something called the 7mint2, so that's weed. It's a class that we're not really familiar with, but what I could do, assuming internet works and everything, I can select this specific envelope and ask whether it's obtained in other videos. You see, and then I have more cases where I have this specific envelope, and then I can start explore the data set in order to see whether there are objects of interest. So for example, here there are is doing a lot of money, so why not brag about it? Let's see which one is interesting. Yeah, here there's, I don't know, it's medication. Yeah, so there are a lot of things. So basically what I could do, once I find an object of interest, I can find and basically mark those objects. Let's see. Okay, I'll start from this one. You know Solo? You don't know Solo. Okay, so that's another type of drug. Let me try this one. Maybe it will work better. Yeah, so we have different types of drugs. I can define the classes and then put a rule that whenever I want to create a new class, and this I did ahead, oh, something is messed up. Yeah, sorry about that, some demo bug. But basically I could create a rule and start creating new classes based on the data. So let's continue with the real slides. And one of the next thing we can do, besides finding specific objects of interest, we can ask, can we find a sequence of occurrences, which could be interesting. So for example, dangerous driving should be interesting. If you remember, it's the craziness factor, the dangerous things. So what we could do, we can define a rule that says, find me some video, there is a road and a vehicle and a person and I don't know, or a motorcycle and something, and then try to find groups. Now, if you understand my bottom line, whenever you have outliers, there is also outlier to the outlier, right? So the question is, what's the most crazy dangerous driving? So I did prepare an answer. I'll try to show you online, hopefully, if the internet will let me see if TikTok will be nice to me. Oh no, that's unplanned, sorry. There is a user called Dumbface Kitty. I think that's the name. But if not, I have the video captured. This one. So this user dresses as Kitty, rides a scooter, but it's not a regular scooter. He changed the engine of the scooter that it can drive 90 miles an hour. And he's competing with cars and other motorcycles. So I would say that's the outlier of that, at least the one that I found. It's the outlier of the outlier. Yeah, so here, this one I'll skip because I showed it on the real demo. Yeah, so if we summarize, what are the benefits to the thing where the platform that we're building is first we went to the stage that we have no clue what's going on to the way we have a graph which analyzes the full view of the network to get the full visibility, and that way we can quickly interact with it and find the areas of interest. This makes our work with visual data way more efficient because we don't need to manually label things or to write code or to write scripts and so on, and we can be way more effective when dealing with visual data. Our tool can run both on-prem or in the cloud. It depends on the customer and what's the level of secrecy of the data. And we are super scalable. We are the most scalable tool we know. Largest customer up to date has 100,000 hours of video. So that's pretty much. If you translate it to video frames, you get hundreds of billions of video frames. So that's a very big data set. Now, if we recap what last year lecture to this year lecture, so last year I had to work really hard, look at the visual data set, write some code, write notebooks, find a funny example, and show it and tell about it to the team. But this year I can just go to the platform, type a ship on a motorcycle, and actually I can find more instances of ships, because this is an outlier, but there are also other similar outliers. So our platform is free for evaluation. You can immediately try it out. It's app.visuallayer.com. And this is me. I would love to hear from anyone who has large volumes of visual data and needs any type of help in this domain. Thank you. And I would love to take any questions. I guess we have a few more minutes. Yeah.
How did your platform know what crazy driving is?
Yeah, that's a good question. Yeah, that's a good question. Yeah. So when we can define a sequence of operations. So basically, we can ask for a video, for example, that has in some frame a vehicle, in some frame a person, and we can also define something of the abnormal, like if he's doing a wheelie on a motorcycle, that will be, the motorcycle will be in a weird position, or if he's doing crisscrossing, or those things will come up as an outliers, but the thing here is there is also a sequence, not just, because using one frame, it's really hard to know. Yeah, no, so here we gave multiple instructions. It's not that easy to abstract. And this is something we didn't yet fully release as part of the platform, but that's kind of the next things we are thinking about. Yeah. Are you pulling in the metadata too? Yeah, we can also feed in customer metadata and then do searches based on a combination of your metadata, our enrichment, which describes the data, and also visual queries. But the metadata from the video, for instance, on TikTok? No, TikTok strips everything to, yeah. You can't pull in like any description or notes or anything that people would add? Yeah, whatever you like to add, if it's available, we can add it, but on TikTok specifically, the location and other metrics are scraped on purpose. Yeah. Mm-hmm. What is the primary workflow? They use it as it does out of the box, or they have some workflows where they are using it? Yeah, so we have two main use cases. One is data analysts, which basically looks for things in video. So it could be homeland security or sensitive things like or law enforcement, where you want to find a specific instance. So you had a suspicious car and you want to find where it was from other viewpoints in other cameras. So for them, once they find the object of interest, they are done and they are happy. The other type of use case is data scientists, where they need to build specific models. So for them, it's really hard to curate the data, find examples, iterate, annotate, go back, and so on. So for them, we help to speed up this process of finding the interesting things. As I showed the comparison between finding a ship on a before you have this infrastructure, if you needed to find a ship on a motorcycle, you had to annotate 1 million images. It was really hard. But now with our understanding and the enrichment, we can find those occurrences very quickly. Sure. I don't think we have a real competition because of the scale. We are way more scalable than anyone we know. We have a demo that up to 1 billion images on a single multi-core machine without GPU. So we are really on top of the top of the scale. Okay, so you do both images and video? Yeah, both images and video. Yeah.
How does this work as far as like fair use? Like if someone wanted to use your database to search for like fair use footage could be used for other to create new videos, would that be another thing?
What do you mean fair use?
Like if I'm gonna upload to YouTube, and I cut a piece of something from another YouTube video.
Oh, yeah, that's very common. Yeah, so that's a great question. So the main problem in social networks is redundancy, because if there is a popular video, people will repost and repost it and add their logo or add a title, and it's a huge headache. And once you do enrichment, you need to pay GPU for a huge amount of information, and it contains no extra value. So what we do in the first step, we do reduction of the video data. We reduce, on average, 98% of the video data, keep only 2%, and only that we use GPU. So we have very good understanding if a video was resized or cut or copied and copy-paste and so on. We can point and tell you what was the original, what was the derivations. Yeah. Mm-hmm. Yes, last question.
I actually have a question. I thought you might not know, but since you just made these comments about how much you know about the image, I have a question about this called like deep fakes. But basically, if the video or image was manipulated, and given how much you process and know about these images and videos, do you think that your algorithms and your technique might be used to identify these deepfakes?
Yeah, so we don't work on deepfakes at all. What we could help with, if you have original data sets that we can relate and tell you this was borrowed from another data set, and because deepfake are often replays of old video and a bit tweaks and so on, so we could find the source. And in fact, there was a paper from Berkeley by Eric Wallace that showed that generative models are violating copyrights. And under the hood, he used FastDupe for finding the duplicates. But there are specific companies that also claim that's their forte, but we don't deal with that.
Okay, thank you.
Thank you.